Hello, and welcome back to this series on building a library from scratch in the language C. And previously, I was working on making a linked list, and I did a little work off camera that I'm pretty excited to show you. So if you remember what the challenge here was, it was that in C++, I was able to create this linked list so that it was very dynamic. I could basically put any kind of data I wanted into the linked list, and by using this class template that the language provides, I was able to essentially change what kind of data was in the node on the fly whenever I wanted. And C does not, by default, offer that same sort of dynamism. And I've actually found out a way that I can get pretty much the same thing. So today I'm going to show you what I did off camera to create a dynamic array or linked list in C, and now it can handle any data type, including arrays. And it starts over here in this node.h file. First, I created an enumeration called data types, and this provides a list of names that will get integral values. So special refers to the number 0, int refers to the number 1, long refers to the number 2, etc., etc. And then for my nodes, I included a data type and a size parameter in this constructor that I created. So let's go look at the actual constructor. So over here, what happens is the user is going to put a void pointer to the actual data that they want to store. Then they're going to use that enumeration to specify what kind of data they want stored there, and then they'll say the size of the data. And then what we'll do is come in here. First, we'll check to make sure that the thing they're trying to store actually has a size. It can't be 0. And then we're going to use a switch statement to determine what kind of data they're trying to store. So let's look at this first case where they're trying to store integers. What I do is call malloc in here. And by doing this, if you remember previously, in my test case, I had to call malloc before I inserted the node. I had to allocate the data and then call the function to insert a new node in the list. And what I've done here is create this constructor for the node that calls malloc for me. And the challenge here was in being able to specify what kind of data was going to be allocated. So you can't pass just int itself into a function. So if I was going to create this constructor, I can't just pass it int. I have to somehow tell it that there's going to be an integer without actually directly passing in int. So that's where my enumeration comes in. I can have this integral value representing integers that will allow me to call this particular case. And in this case, I can send it an int. And well, I know they're going to be using an int because they said they're going to be using an int. And the extra benefit here is that I can also specify size. So remember, malloc takes the size of the memory that you want to allocate in bytes. And so if you take the size of integers and multiply it by the number of integers you want to store, that's how you create an array. So if this is one item, we'll just store 1. But if I have an array of 50 items, I can use this exact same function to put all 50 items into my node. And using this, I can just, in the future, add new data types to this enumeration, copy and change one of these cases, and I can just add to this as I go. Additionally, the default value is, or what I refer to as special in the data types, is anything that I don't know. And this way the user can create their own custom structs or data types, whatever they want, and pass it into the same function. Now they're going to have to call malloc themselves outside of it, but that's fine. They know what they're doing at that point, and they can do that. But here, for all of the generic data types, whether it is a single value or an array of values, my constructor here is going to handle all of that. So I'm very pleased with this. Also, I had to change some of the functions for linked list and queue. The first one I want to point out is actually in queue because most of the ones here are just adding the parameters for data type and size, and that's straightforward enough. But in Q, there was a significant change that I had to make. So before we had the functions push and pop, and now I've added the function peek. And the reason for this has to do with the way I was destroying nodes. So remember, when I actually call the function to destroy a node, it is going to first free the memory that is associated with the data stored in the node, and then it is going to free the node itself. And if I combine that with this constructor, it always returns 0 as the data type, or null, depending on what kind of data you're storing in there. And that's because I get the memory address as my return value, but before I actually return it, I free that memory space. So my real question here is, that makes perfect sense. In my pop function, I was calling this destroy prior to returning the value. So my question is, why wasn't it doing that before? I really don't know. It took me a while to figure out what was going on here. And once I did, it actually made more sense than the original. So I don't know why the original was returning values at all. As far as I can see, it shouldn't have, but something was going on there where it did. So it's a mystery. But now it is working because I have created two separate functions. So peek is going to just get the value or the data out of whatever node is at the front of the list. And then separately, I'm going to have to call pop. So that's basically all I had to do. And just to point this out to you, I've changed the destroy node function slightly. If we look here, instead of calling free directly, it is calling this new function I created called the node destructor. Now in C++, when you have classes, you have constructors and destructors, but I'm having to do this rather manually. And so my destructor here is going to do exactly the same thing. First, it's going to free the data, then it's going to free the node itself. So it's pretty simple. It's really just a semantic or aesthetic thing that I did this just to have a constructor and a destructor for the node itself. And that is basically all of the changes I made. And I want to point out one other thing. I moved the parameter of passing the object itself into its own function. So this is one of the things that I didn't have to do in C++ with my classes. I can just refer to the parameters of a class by name and manipulate them directly. But here in C, I actually have to pass a reference to the item itself into its own function. And this isn't as strange as it seems. I'm going to create a new file over here just to demonstrate this. And it's going to be empty. And I'm going to call it test.py. So this is going to be a Python file. And what I'm going to do is define a class. So let's say class example. And I got to make sure I get my syntax right here. Now I'm switching languages. So let's define the constructor for this, or init in Python. So we'll say def underscore underscore init. And let's say I want to pass it the values x and y. Now there's something I'm missing here. I have to actually directly pass this self. Now when I actually refer to this function outside of the class itself, I don't have to pass self in. But in this definition, I do need to have self. And that's exactly what's going on here when I am putting in a reference to the object itself. I am basically having to pass in this self that we see in Python. But this is not a Python library, so I'm just going to delete that file. And that is all. So I want to demonstrate the real, what I think of as beauty in this implementation of the linked list. I can create dynamically, and so I have this for loop to do this 10 times, and each time I create an array, and the array contains 3 integers, I plus 1, and I plus 2. And then I'm going to push, also referencing self, the address of x, my array. I'm going to say it's an array of integers, and then I pass it the number 3. Remember that this int refers to my enumeration, so that's how I'm using that case, that switch case statement in the constructor. and then this refers to the number of items in the array. And then what I can do is, in the second for loop, I can just print all of the values. Now, I still have to cast the return of peak. I have not put in anything to do that automatically. That would require separate functions for every single one, and I think it's actually easier just to have the user cast what they are trying to get, but I can reference each individual item of the array. The other inconvenience here is that after I use peek, I then have to use pop to remove it manually. So one extra line of code, but to me this is a lot cleaner than having to actually call malloc out here and have the user do that manually. Here they can just say, I have this data, and just put it in. If I wanted to, I could also just pass in I, and then this line would be unnecessary. So essentially one line of code is all I need to work with this linked list. And we list there, and I put that in the wrong spot, but that's okay. Now I'm going to run this file, but I'm probably going to have a cut right here because Xcode is updating and GCC is not currently available. So if that happens, we are going, you can see right there, there's my error message. Let's just give it a try. We need to wait for it to update, and I will be back shortly. Well, it's unfortunate that I cut there because I was doing well on a one-take wonder, but that's okay. I have a few other things I want to point out while I'm doing this. First of all, in the node itself, I've added a few additional parameters. I'm storing the data type and the size of the data, so the number of elements in the array, in the node itself. And I don't really use this yet, but I'm thinking that there probably is a way for me to use it in the future. Just like I was able to use the specified data type to create the node, I'm thinking there might be a way for me to use it in order to get the data out of the node, thus preventing the user from having to cast it themselves. And I think part of this might be in my retrieve function in this one. Actually, let's look at the header file. So you see here in retrieve, I return a void pointer, and it just retrieves the data. But maybe it would be better for me to retrieve the node. And the reason I would want to retrieve the node instead of the data is that this linked list has no controls over what kind of data you store in it. You can have the first element store an integer. You can have the second element store a character array. You can have the third element store a Boolean or a struct or absolutely anything. So there are no limitations on how I would use this linked list. And because of that, the user might want to be able to reference the type of data stored in the node in order to know what to do with it. So I'm thinking I might change my retrieve function to get the node itself rather than the data stored in it. And I'm not sure about that yet. Maybe I will do that. I think I probably will. I'm still thinking about it. Maybe there's a way around this, like how I did something clever here by using my enumeration to create the node. Maybe there's something else I can do that I haven't thought of yet to actually get the data out of the node in a cleaner way. But we will see. I believe I'm still waiting for Xcode to update. You see, it goes through this part extremely quickly, and then this tiny little gap right here, it's been a few hours now, so we'll come back in a little bit and I will demonstrate the code for you. All right, so just to refresh, in this function that I've created, the main function, we generate a queue called list, which is unfortunate naming, and we do that with the queue constructor. We then have this for loop create 10 arrays of type index, each with 3 elements, I plus 1, and I plus 2. We then push all of these one at a time into our queue, and we pass it a reference to the queue itself, that is our self variable in a Python context. We pass it the address of the data we want to store, which is our array. We say that this data is of the type int, and we say there are 3 items in each array. And then we go through and we print each thing one at a time using peek, and then destroy them as we go with pop. So this compiles just fine. And if I do a.out, you can see that it prints out all of our arrays. And this is fantastic to me because now I can, in my linked list, store any kind of item that I want, and it's always going to behave the same way when I manipulate it like this. So for example, if I just want to put I in there, instead of that, I can do that. And we need to fix this. So the point is that I can dynamically get whatever I want out of this array, and I can put whatever I want in this array, or not even array, this node. I can have any kind of data I want in this exact same linked list. And what am I looking at here? I need to dereference that. Yeah, I can put any kind of data I want into this linked list. I can put character arrays, I can put integers, I can put nodes, I can put nodes inside of nodes. I can put a linked list in this linked list if I want to. It's fantastic. And all of that will always work. And like I said, there are some performance sacrifices here, but if I need something that performs the minute amount faster that it would to do this all manually, I can just make that instance of it. What I'm going for here is a set of tools that will fit pretty much anything. And in those cases where I need a more specialized tool, that's when I can make that. So let's run this new version, and you can see it's going to print out our numbers. And let's put in a character just to demonstrate that, because this is exciting to me. And we're just going to pass it x. And it's not an int anymore. It is a char. And I should have done this on the first one, but I didn't. I should change that to 1. You can see it still works, but takes out some unnecessary error. Oh. Apparently there's a problem. Where is that? Set a breakpoint in malloc error break to debug. Pointer being freed was not allocated. Interesting. It looks like I have some debugging to do. Let's take a look. That's going to be happening in here. And it would be in the char. Node.data, malloc has a char size. Interesting. This is exactly as it was. What's going wrong here? Two, 6, 5, 7. Oh, let's see. Let me do something real quick. This is not the problem. And is it C for this? Oh, okay. And this needs to be a character. Is that all good? Let's try that. I know that's not going to solve the problem. Turns out we are going to do some programming today. Yeah, so it doesn't work on B, the second item. And why would it not work on the second item? Because it's crashing here. So it's crashing on pop, which is calling the destructor of the node. I thought I had debugged this whole thing. Silly me. Let's see. Node data. And I'm passing it the node. They're all exactly the same. Well, I'm going to have some debugging to do, and I'll come back to you. All right, I got it working. If I go ahead and compile this and run it, you can see that it will print the letter X 10 times. And let's see, X, Y, Z. And we're going to say this is 3. And I want to print not the dereferenced, but let's do that. And let's say 2. We'll just print the last thing in there. And need to specify that this is 3. So if I run this, I'm frazzled, guys. Sorry. Here I was excited that this whole thing was working fine. So yeah, now it is working. I'm only printing that element. And the problem was in node.c, and it seemed like when I freed the pointer to the data, it would then also free the node, but only when I was using an integer. So I don't know what's going on there. I'm gonna have to do a little research, find out what's going on. So we're not done yet. But as you can see, we are clearly on the path towards having this dynamic list. And one might be wondering at this point, why bother with all of this? So it was much easier to set all of this up in C++, of course. All I needed to do was create a class template and then specify the data type and blah, blah, blah. And part of the reason for me is that it's fun. I like doing this. I like doing things manually. And there's pros and cons to the simplicity of C++. C++ is not a simple language by any means, but they're doing things for you. And it may be that the way that they do things for you isn't the best way to do something. In C, you're having to do everything yourself manually. This gives you a fuller understanding of what is happening on both the software side and even the hardware side. And it also lets you customize things a bit more. I get to decide exactly how this is going to work. So in C++, for example, the linked list implementation that I had there was not as dynamic as this one. I can't put an integer in the same linked list as a string or a character or anything like that. I'm sure there's a way to do it, but at least in the implementation I had, that wasn't the case. So you get a little more custom with something this low level. And again, mainly for me, I just enjoy it. I want to be working at this level of things. So I'm going to keep working on this. I'm going to figure out what's going on here. I think that by removing this free node data, we're creating a memory leak. So by not freeing the data in the node, we are missing part of it. So I'm not sure exactly what's going on here, but I'll do some research and we'll have another update very soon. Thank you again for watching. I just want to mention that all of my code is available on GitHub. You can find the link in the description, and I will see you next time. Toodaloo.